Okay guys, so we're going to be doing a lesson a lot like the previous one. We had just done evaluating arithmetic series, now we're going to evaluate geometric series. Remember, a geometric series is one where the pattern increases by a factor. Instead of by adding a number, you multiply a number. And that's called the common ratio, which you can find by dividing the second number by the first number. So we see that in this example, this goes up by multiplying by 3 each time. So that makes this a geometric sequence. Geometric series, basically you replace the commas with plus signs. And I don't know why that little mark is there. And then you add that together, and that is the geometric series. But a geometric series can also be represented using this sigma notation right here. And it's sort of a shorthand way of writing a formula. What it means is you plug in a 1, which is 3 to the first, then a plus sign. The sigma means plus. Then you plug in a 2. Then you plug in a 3. Then you plug in, when you get to this top number, 4, and then work that out. 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81. So it's the exact same pattern as that one. It's just presented in this sigma notation. So we want to add these together. Now, like I said before, you could just type this into a calculator and get an answer. 3 plus 9 plus 27 plus 81. However, the goal is to get you to be able to use this formula and to be able to use it when you're given the pattern just written out like that with the plus signs, or if it's given to you in sigma notation. Now with any formula, you have to know what the letters stand for, the variables stand for. Sn is your sum, so that's just the answer you're trying to get. A1 is the first term. So here we see A1, that's the first term in the series. R, the common ratio, so you're going to need to plug in the R twice. And then N is the number of pieces or elements within that sequence or series. N is either going to be flat out given. The problem will say, hey, N is 7 in this problem. Or if it's not given that way, you need to know that N is the number on top of the sigma. I know that it says N equals 1. That's like the starting point. The N in the formula is the N, which is the ending point. So you need to know that. All right, let's look at number 2. So this is a pattern for -8 plus 16 minus 32. And we are being told that there are 8 elements. So this is one of those problems where they flat out give you N. So let's review. You need A1, you need N, and you need R. R you can find by dividing the second term by the first term. -8 divided by 4. Actually, you can divide any term by the term in front of it. I'll just stick with this second term by the first term to keep it consistent. So R in this problem is -2. N, as we see here, is 8. And A is the first term. A1, rather, is the first term right there. It's 4. So I need to plug those numbers into this formula. Let me write it down one more time. So there we go. So our sum is going to equal 4 times 1 minus -2. Remember, put negatives in parentheses, to the 8th power over 1 minus -2. If I type this into Desmos, it should just flat out give me the answer. So 1 minus -2 raised to the 8th, 32, that should be -2, all over 1 minus -2, and we get -340. Let's check the answer and see if that's right. And there's a check mark right there. It is right. All right, repetition is good, and repetition is good. So let's do this again because repetition is good. So what are the 3 things you need? The first term, that's 1. The N, they flat out tell us N is 7. And the common ratio, which you get by taking 4 divided by 1, which is 4. So we need to work this formula. S equals 1 times 1 minus 4 to the 7th power over 1 minus 4. All right, let's do this. Fraction bar, 1 parenthesis 1 minus 4 raised to the 7th over 1 minus 4. And I come up with 5,461. Let me see if that's right. 5461 right there. So what that means is this series, which as it's written, there's only 1, 2, 3, 4 terms. If we wrote it all the way out to 7 terms total and then added that all together, this is the answer we would get. The formula should be the quicker, easier way to do it. Okay, for the rest of this assignment, we need to apply this formula in sigma notation. So once again, I'm going to write the formula. Maybe well, you know what? It's up there. I'll just keep scrolling up and down. We need the same 3 things. We need A1, N, and R. Okay, so what's A1? This is actually the most complicated part. A1 is what you get when you plug a 1 in and work it out. So we need to do 3 times -5 to the 1 minus 1. Now you can work this out in your head. It's actually surprisingly easy, even though it looks complicated, but I'll work it out here. And, oops, nope. Look how I have to do that power in parentheses like this. And this works out to be 3. And the reason why 1 minus 1 is 0, anything to the 0 power is 1, and 3 times 1 is just 3. So A1 in this problem is 3. N is 7. Remember, that's that top number. That's going to be your N, the top number. R, now you might think R is difficult to figure out. R is always the base of the exponent. So R is going to be whatever is in parentheses right here, and it's just that simple. There's a longer way I could go into explaining how the formula works and everything, but what it's going to boil down to, R is always the number in those parentheses. If you look at your assignment, okay, so R is in parentheses, R is in parentheses. This one doesn't have parentheses because it's not negative, but R is that number right there, the 4. Not this 4, not that it matters. I mean, they're both 4s, but technically this number could be something different. But so R is the base of the power. When it's negative, it's in parentheses. If it's positive, it looks like it's not going to be in parentheses. So in this problem, R is -5. So I need to do the formula. Sum equals fraction bar A1, which is 3, parenthesis 1 minus R, which is -5 in parentheses, to the n power, 7th power, over 1 minus R, which again is -5. I should be able to just type this into Desmos and get my answer. So 3 parenthesis 1 minus parenthesis -5 parenthesis raised to the 7th power, and then down below 1 minus -5. Ooh, that's a big number, 39,063. When I get big numbers like that, I get a little cautious, a little concerned. Did I do it wrong? Nope, that's it. So, just like the last problems, A1, N, and R are what you need, and then you plug them into this formula. Unlike the last problem, you got to kind of know where to extract these numbers from by understanding that notation. So, since repetition is good, and repetition is good, let's do number 8. So we need A1, N, and R. A1 is the first term. It's what you get when you plug in a 1 right there. Let me go ahead and use the calculator. -2 parenthesis -4 parenthesis raised to the parenthesis 1 minus 1. Oops, not 11, 1 minus 1. And that works out to be -2. N, the number up here, 9. R, the number in parentheses, -4. Let's do the answer. Sum equals -2, 1 minus -4 to the 9th power, all over 1 minus -4. All right, let's see what happens. I'll do my fraction bar first. -2 parenthesis 1 minus another parenthesis, -4, close that parenthesis and raise this to the 9th power. And then on the bottom it's 1 minus -4, -104,858. Ooh, that's a huge negative number, but it is correct. So this is one where if you were to try to work this out by hand, would take forever, but the formula gives us a quick, easy answer. Again, I think the biggest challenge is, do you know how to get these numbers out of that formula? All right, let's do this one more time. So we need A1, N, and R. A1 is the first term. It's what you get when you plug in a 1 here. 2 times 2 to the 1 minus 1. I believe the answer is going to be 2. 2 times 2 raised to the 1, parenthesis, 1 minus 1. Yep, 2. N is that number, 9. R, the common ratio, that's the base right here. In this case, it's positive, so you see there were not parentheses there. But R is positive 2. Let's do the formula. S equals 2, that's this 2, 1 minus 2 to the 9th, so that's this 2 to the 9th, all over 1 minus 2, again that's that 2 right there. So 2 parenthesis 1 minus 2 raised to the 9th, all over 1 minus 2, and I come up with 1,022, and that is the answer. So there. Now you see how to evaluate geometric series, whether it's given as an explicit list or whether it's given in sigma notation. I'm going to erase a little bit of what I wrote here before I save it. That way if you use this for your homework, remember do the odds. Now you got a fairly clean slate to work with. All right, good luck. Contact me through the regular means if you have questions, and have a great